Hello everyone. In this session of CCNA series, I will discuss about IP routing. IP routing is a process of forwarding IP packets from a device that originally builds it to the device that is supposed to receive it. In simple words, I can say it delivers IP packet from the sending host to the destination host. And this routing process is usually done by the device called router. Let's go ahead and have a brief overview of what IPv4 routing process is. From the host perspective, the routing process starts with the host that creates the IP packet. Before forwarding, it will first ask the question to itself: is the destination IP address of this packet in my local subnet or remote subnet? If the destination is local, it will send it directly to the destination. For example, host A wants to forward the packet to host D. Here you can see both are in same subnet and they are directly connected. Host A will forward to the switch and directly to the host D. What if the destination is remote? For example, if I want to send a packet to host B, so the destination is remote on the other side of the router. So therefore, a host here will send the packet to the default router, and you can call this default router as a default gateway, and this router will forward it to the destination, that is host B. If you look the routing process from the router perspective, it has more routing work to do as compared with the host. So when a packet arrives, the router follows 5 steps. Okay, the step 1 is to decide whether to process the incoming frame, and it does this based on two things. First, it checks if it has a FRC errors, and then is the destination link address its own address. If these two things are confirmed, if there is no FRC error and the destination data link address is the router's address, then it goes to the next step, that is de-encapsulation of the IP packet. Here, it de-encapsulates the packet from the inside of the data link frame. As you can see on the right below, the packet has been de-encapsulated. Here, the destination IP address remains unchanged. As you can see, I am forwarding the packet from host A to host B, so the destination IP address will be 172.16.2.9. Then it moves on to the step 3, that is to choose where to forward the packet. On this step, the router will decide where to forward the packet next, and it does this by looking at the IP routing table. Here it compares the packet's destination address in the routing table. For each route, uh, it is used to match the destination address of the packet, and it identifies the outgoing interface of the router and possibly the next hop. As you can see in the routing table, here it shows the forwarding instruction for 5 different routes. In our case, the router matched the route for subnet 172.16.2.0 because our destination belongs to this subnet. So R1 will forward the packet out of its own interface, that is S0/0/0, to R2 next listed with its next hop router, that is 172.16.4.2. That is the next router's IP address. The next step, step number 4, it will encapsulate the packet in a new frame. So since the router knows where to forward the packet, but it cannot forward it until it encapsulates it with a data link header and trailer around it. Once this is done, it moves on to the next step and the last step, that is step 5, transmitting the frame. So once the encapsulation is completed and the baggage is ready, the router simply needs to transmit the frame. And it does this by using ARP protocol, as it is needed to find the next device's MAC address. I hope this session was informative for you. Thank you for watching.